I think the screen is visible, right?
And when you are done today, you just tell me. I'll just start the quiz at the end.
Okay. Yeah.
Or do you want the quiz in between or something?
No, in the end would be fine
In the end. Okay.
because it's a total quiz.
Okay.
Okay, so let me start. So first of all, I don't know how many of you have actually correctly installed the root. Some people were complaining that they cannot import a root.r data frame. That I checked that for some versions or some specifications, you cannot actually import, for example, root. Let me just do it. Uh, so, for example, let me show that Python, and then if you can actually import this one, then it's okay. You don't need to import root.r data frame, which is working in my system, but in some system it is not working. Okay, so if you cannot do it, that's fine. There is a workaround by which you can do it. So I will show the example with that workaround. So you don't need it. Okay, but for my case, it is working somehow. Okay, and second thing is that I have actually already shared a link with you for the Slack workspace. Okay, so and I have created a channel. If you cannot find the channel, then you can actually go here and uh, go to browse channel. From there you can actually find the channel and you can join. And if you have any questions, any queries, like which needs a lot of discussions and other people might be able to help you, then you can just post your comments here. And with I think you can post images also, like screenshots and etc. Okay, so then I myself or some other people can also answer your questions. Okay. Right. So that's one thing. Then now let me come to the part of like the thing that I intend to do today. So I just like introduced you to the root framework to some extent, and mainly this part that I have told you earlier, that the data in the data handling part, data are stored in a T file, okay? And then it is stored in a structured and hierarchical format, which we'll be exploiting today again using something called R data frame. Okay, so where we saw that we have a T file, and then inside this T file you can have many T trees. Within these T trees you can have branches, and then the leaves. Leaves are the ones where actually the actual value of the data are stored. So we will be needing this concept and I'll start from there. And then we showed some example with basic root, how can open and see the what are the keys and all these things, and then how you can do some of the examples. And then we showed that, okay, so what are the data stored, what are the branches that exist, and printing all of this can be done, and what are the branches, and then how can you do it. And then in the second example, but we saw that the same root file can be read by uproot, which is another like a very good package that you can use and integrate with awkward to do a real-time analysis and an actual analysis in a very convenient way. And we showed some example here with that how you can get the keys, how you can find the like construct the arrays from the branches, and so on and so forth. And then you can actually use awkward array to get the values and flatten it. All these things you can actually do. And then you can actually select events based on some criteria. But what you can see that here in these examples, you have to like uh, like do a little bit of work to do this masking thing and criteria fixing all these things. So today I will show a better framework called R data frame, where you can actually do it in a very intuitive way. So that will we are going to do. So this is the R data frame that I am talking about now. So it has many flexibilities, and it's like um, it's like the data frame that you already learned, like pandas data frame. It's somewhat similar, but it has some enhanced capabilities also. You can integrate with some I mean with the pandas also, like some modern Python 3 modules. At the same time, you can, in some cases, you can write codes in C++ and incorporate it within this and do your analysis. So it has much more flexibility than the pandas data frame. And more importantly, it is created around the root framework, so you can easily read and read the root files. Uh, those are very very common in the high energy physics community, and then you exploit the T tree, T branches, and T leaf structure in terms of the column names, and easily do your analysis. And what important is this follows something called a lazy evaluation. By lazy evaluation, I mean that this whole thing will be like just defined in to begin with. It will be defined, only the functions and everything will be defined, nothing will be executed, so it will not overload your RAM. And then it will be executed only when it is called for, something is called for, not the entire data file will be like loaded on your RAM and you have to do the work. So that's not the job of this. So that's the enhanced lazy evaluation that we have. Okay, so let me now start with some of the examples. Okay, so as before, you just have to import root in Python. So for example, in my case, it is like 6.28. So I ask you to do it at least 6.26, so that you can actually use these things that I am showing. Okay, then the next thing that it can do is you can actually enable multi-threading. So if you want to use the enable multi-threading option, that is the execution when it will be called for, it will be done in a multi-core fashion. Then you can actually do it by calling this command, enable implicit empty. So empty is multi-threading, and you can check whether this is enabled or not. Okay, so in this case, is multi-threading enabled? It says true. Okay, but in this example, I will not be using multi-threading. In some cases, it creates some problem, because not all of them can be multi-threaded. If there are something which is sequential, you cannot actually do multi-threading. So for this exercise, I will disable the multi-threading, and so this will show false result. So now come to the concrete thing that we will be doing. So first, what we have to do, so just like yesterday, we have uh, mm, we have this we have this uh, root file which has the data inside it. Okay, so I have sample one, in which that I shared last time, has the data in a T tree and T branches structure, and tree name that, if you remember in the from my earlier examples, the tree name is actually data. Okay, so let me see the tree name T tree here is actually, name of the tree name is data. So that is how you actually create the R data frame from the root. So root dot R data frame, and the syntax is you give the tree name and then the name of the root file. Okay, so this will create the R data frame for you. Okay, so now if you want to check that what it is, it will say that this is a Python object, which is type is R data frame. Okay, it holds it's an object which holds this data type. Okay, so now just like before, if you want to know that what are the columns that exist, that is meaning that here columns meaning that the branches that exist. Okay, so then for that, what I can define is that from this data frame, you take this get column names, and if you print, then you will see the branches that exist within this root file. Okay, so this is the branches are essentially the HT, MET, MET5, just like before, and then the example that I was showing are where like jet pt, jet number, muon energy, and all this stuff. Okay. So then if you want to check that which column the format or column type is what. Okay. So for example, JPT column type, earlier we saw that it was a vector rvec type object, and with like float, each element in this rvec is a float. So if you remember that, then it's like it shows that. And let's say HT, these are kind of event variables. Okay, so if you see, then you will see that this is a basically float type object. It's like the data type is float. So in each row, in every row, a float number is stored. Okay. Now, if you want to see the whole data that you have, just like the pandas in a tabular format, the pandas gives you, here also you can see it by this command. Okay. So if you say that df dot display, and then if you print it, you will actually see the data that are stored here. Okay. So if you see that ht is a float type object, met is float, met phi is also float, electron e and eta are not shown because if you remember from our earlier exercise that uh, for the first event 08, like this one, there were no electrons. So and up to fifth event there were no electrons, that's why nothing is shown here. And then there are like more columns which are not shown here, otherwise the whole RAM will be overloaded and all these things, so they just cut it at some point. There's only 8 columns has been shown. But if you want to, let's say, want to view a few specific columns, there are ways to do it. In that case, what you can do is you can specify that which are the specific columns that you want to see. So, for example, you want to see, if you want to see JPT, JETA, and MET, then you put it in a list, and then you print it. Okay? So you can define a separate list if you want. For example, here, if you see that if I print it, it shows that JPT. Now, if you remember that JPT is not a single PT, because each event has multiple jets. For example, for the first event, it has 10, 10 jets. So there will be 10 entries corresponding, 10 PTs corresponding to each of the jets. Okay. And then jet eta will also have 10 entries for the first event. And MET is a single float type variable, so that is shown here. Okay. For the second event, also third, fourth event, it shows all things. Okay. So that's the advantage, that if you want to see a specific or the format of the specific column, that you can do it very easily. Okay. Now, if you want to see that how many entries are there in this data frame, okay, then you can see that okay, this df.count.get value will give you the number of entries that you want to see. Okay, so it says that 50,000, meaning that there are like 50,000 events or 50,000 rows in this whole data frame. Okay. Another way to display it by, let's say, another way to display it, let's say you can actually define preferred column names. Let's say select column, okay, and select column. Well, this. So you can actually list it in a select column, and then you can again display it. Okay. So that's another way to see it. Uh, that's the thing. And then you in high energy physics scenario, what happens that you might have lots and lots of data, okay, and those data, let's say, with the same format but are stored in separate root files. So what you can do, you have very flexibilities here. What you can do, you can actually define a, let's say, list, or define a list, or there are other examples with T-chain also you can do it, that I'm not going to show. But in the Python, what is much more natural is you can create a list containing the list of files that you want to like analyze. Okay? In that case, what you can do is you write this For example, in this case, I have sample 2 and sample 1, um, and these sample 2 and sample 1, I put it in a list, and then we can actually create the data frame. Okay, let me show you that that this is a new data frame that has different values, because each of them contains actually 50,000 events or rows. And now if you see that the number of rows that it shows is 1, that meaning that it actually takes the full data from this and this. And then again, just like before, you can see the column names. In this case, it will be the same, and you can again display the whole data set. Um, I mean, some part of the data set into your screen. And there is another important functionality. Is, let's say if you want to analyze only first 1000 events. So this might be required, for example, when you want to start your full run, but if you want to check that whether your code is working or not, and each time loading the whole data set and executing it will be cumbersome. So what you can do is you can like select a range, and you do the test, and then later on you can like start the full run in a big computer. So in that case, you can actually specify the range. So in this case, what I define is df to be out my new data frame. Okay, with so this range I specify, if it is a single number, that then it will use only the first n number of rows or if. But if you want to specify range from, let's say, some n1 to n2 values, then the command is syntax is this. Okay? So then let me show you that. Okay, so let me show you. Uh, Now that the count for df is 1000, and count for df subset is should be 2000. Um, is that question? Why? Oh, so I said um, I've already created df to be. Okay, let me reload the data first, then do it again. I see. The reason behind is that df has been redefined as like 10,000 entries. That's
There
I
is a
told.
question in the chat box.
So for multiple root files, the root files can have different trees. No, no. So you have to have the same name, same tree name. With different branches, yes, that you can have, but different branches, then you will not be able to use it. It has to be the same branches, but tree name has to be the same. Otherwise, it will. I mean, it will add the two data files. If there are like two different trees, then what it will do is whatever tree. So, for example, here, yes, here, for example, you have to specify a tree name. And now if your second data file has a different tree name, it will simply not load that data, right? It will try to load and it will not see any data, it will not load. So if you have different tree name, it will not load. But for different branches, I'm not very sure actually. So I don't know why you need different branches, because uh, in the same thing, but I never tried that one, so I'm not very sure that if you have different branches or extra branches from the different data file, that I haven't tried. But there are workarounds, like you can actually slim your data file first. Let's say you create few columns in a different root file, and the same columns from a different root file uh, to this one, and then you can do it. Okay, so this, let me, you can actually try to do it and see, and let us know the answer. Yeah, that was an interesting question. I have never tried it. I'll try, and if I can find something, I can. Okay, so this keeps zero because df actually is redefined by this, and hence it does not have anything from 1000 to 3000. 3000, that is why it is becoming zero. I should have like executed it first, ideally, see if that works. Okay, then I have to start with the data frame. Then, then I think it's okay. Just now. Um, okay, so now there are like just I said that you can do your analysis, especially in the HEP collider context, in a very intuitive way. So for that, let me introduce two very important functions and very useful functions in our data frame. One is called define, another is called filter. Okay? So let me first introduce define function. What defines does, let's say if you have some of the columns and you want to create a new column, just like pandas, you saw that you can do some addition operation, subtraction operation, and all these things, and from that you can create a new column with a new name and you want to use it. For example, in our case, let us say that we have ZPT column, which has like each row, each event has like multiple entries in it. Let us say that we want to create a new column called PTE ratio with the with the with the leading PT. So PT of the leading jet and PT of the leading E of the leading jet, and take the ratio of it. So you can actually define this just simply by this. And the syntax is you put the column name that you intend to do and the expression for those columns. Okay? So this should be a C++ expression. Okay? And if you actually execute it, you will see that a new column has been created. I just printed only this new column, and it actually shows entries. And this is simply a single number, and that is what it is showing here. For example, if you want to, let's say, define the sum of all the JPTs in each event. So you can actually use implicit function called sum directly here, and you can do it. For example, from the uh, df1, so I create create a new column, and let me display. Okay. So now if you see that I have created from df to df1. So df1 contains all the new column, all the columns that df has. At the same time, it adds one new column here. And df2 is created from df1, then it should contain all the columns from the df1 and adds one more column to it. Okay, so if you actually want to check whether previous columns exist or not, then you can do what you can do is you can just display, and you will see that all these columns, but that is not shown. And now let's say we want to see whether all the columns exist or not. So these are newly created columns, and let me see the previous columns. Now you will see that all of them actually exist. The similar way, and another thing is that you can actually repeatedly use it. So you don't need to like do in this fashion. Okay, first define one column, in the next you define another column. What you can do, you can like consecutively define it. So df2 define, and then dot define, and then dot define, that way also you can actually do. So for example here, but in this df3, what I defined is let's say now display it. um, okay, so no, display dot, you will see there will be initially it was like 20 columns, only 8 were shown, and now it has 24 columns because I have defined how many, one here, one here, and then two more here. So there will be 24 columns, and those that is shown here. Now, one another thing, that if you already have a column, you cannot define it again, okay, with the same name. For example, if I try to do it now, try to do it with the same name, it will show an error. So that you have to remember, that once it is defined, you can you cannot define. So let's say df3 can be defined, but let's say df3. It shows an error, okay. And but what you can do is you can redefine it. Let's say if you want to say that, okay, my previous definition was wrong, then you can redefine it, and again it's not a problem. So then again you can, it will show the same exactly 24 columns, and so this is a very powerful thing then, that you can actually define in a very intuitive way from different columns. So here I showed some like ratio example, but you can have many other functions and complicated functions that I will just come to, and you can do it. Another important thing that you can do is a filter function, which is very intuitive here, because what you might want to do is that, okay, I want the events with at least 2 jets. Yeah? So that you can actually easily do by saying that, okay, my one of my column was jet number, so jet number has to be greater than 2. So at least sorry, three jet in each event has to be there. Okay, so now if you see that, okay, so this does not reduce any number because all the events at least up to 1000 event in the root file has 10,000 sorry, at least 3 jets. So that's why it is not doing anything extra. But if you, let's say, want that my electron number of electrons should be greater than 0, so in this case there is a special column called electron number. But if you don't have the electron number, then what you can do is you can define in that fashion, and with the length function, and you can actually create this column and put this. So that then you see that, okay, my the number of events in out of these 1000 events that I selected in this range, which has at least one electron in it. So that you can actually do very easy. And then the third thing that you can do in a very intuitive way is that, let's say I want, in the earlier example, as I said, that I want my events to have jets having PT more than 200 and 2 such jets or 3 such jets. Okay, so that you can do it very easily. So what you have to do is, first you have to put this condition that jet PT has to be 200. So this will give you a Boolean number, and then you sum over all those Boolean numbers. Okay? And it has to be, let's say, greater or equal to 2. If I demand, then you will see that, okay, out of this 10,000 event, there are like 900, sorry, not 10,000, 1,000 events, 910 events where I have 2 jets having PT at least, like at least 2 jets having PT at least, yeah, 200. So if you want that, I want my events to be exactly 2 jets having PT greater than 2, that also you can do. Okay, so it says that 445 events having 2 jets exactly 2 jets having PT more than 200 G. And you can do much more complex thing. For example, you select the jets having PT 200, and you select jet eta in the central region less than, so jet eta absolute of the jet eta should be less than 1.5, uh, and there should be uh, at least three such checks. Okay? So if you, that also you can do, and you can actually write a very complex expressions like this, and you can concatenate with your proper expression, with and, with or, everything, that with a proper logical way, and you can actually do it. So that's the thing. So it says that, okay, I have events which has at least 2 jet meeting this criteria in each event. Okay? So that's the number of such event is actually 372. So another example that so just like before in the define case, that you can have uh, two concat, I mean filters simultaneous, one after another, just like before. Okay? So that you see that, okay, so let's say we first select the number of muons to be 1, and then then each muon should have a PT, the leading muon should have a PT greater than 20, and how many number of events we have is actually 63. So it's like before. Now another important part here is that, let's say these are very simple conditions, simple expression, and these are some simple let's say some simple expression functions that you define. What you can do is you can define your custom functions, okay, in a C++ code just like this, and you can actually call it through G interpreter declare, and you can create your own custom variable. So in this, and it can be like multiple lines of code, let's say 100 lines of code with different selection criteria, different thing that in that you can create, and you can still actually use it as a custom variable or custom column. So for example, in this case, what we are suggesting is that we like with the leading jet PT, with the leading jet eta, we create a custom variable called PT star PT times the cos h of eta, that we are creating, and we are calling it a custom variable. Okay, so it need not be the simple function. It can be like I mean, it's a long code that it can actually contain. And if you put it inside this root G interpreter declare, and you can have this custom variable. For example, there are like many jet substructure observables, or like some event variables which requires that you take all the jets and create a, for example, sphericity tensor is one example, and some angular variables are other examples, where you can actually create all these variables and call it a different name, and you can actually store it in a column. Okay? So here is an example of that. Okay? Now one here I showed that, okay, this is a double or float type variable, because each entry in jetpt, especially the leading entry in the jetpt, is a double. But you can actually take a vector here and do your computation. For example, the same function can be defined, let me try it right here. Let's say I define a different custom var 2, and then let's say I want my leading PT, but I will pass on the jet PT directly. So then what you can do is what is the type that I have to find? I'm not showing anything. Okay, so here. So let me get So this is root r break float. So what we can do, we can use this type directly here. That is, let's say z et, and then eta is also of that type. So z eta here, and then I want the zeroth component from it here, and directly zeroth component. So, so, uh, so now let me set custom to what it is. Okay, it says some error. Uh, so it should return float to. Anyway, so this way you can do, but somehow it is not working right now. Um, customer 2, customer 2. Also, it says that the previous definition, so it has already been loaded when I started this. So comment this out, and it works actually. So the first time I ran it, so this was executed, but this did not, and that's why it was loaded, but this was not loaded. So it was showing some error. Now you can actually see that, okay, whether my these same thing actually works or not. So there are not unique way to do it. It, it's not displaying custom. I see. I see. So it should not, because now the custom is no longer there. Only the custom key is there. Okay. So now if I let's say rename it to be, let's say, custom df9, and then I redefine it here, and then I display custom and custom 2, it should show me the same identical result in the two columns. Okay. So that's another beautiful thing that you can do. So you need to know a little bit of C++ here in order to define such functions. Okay. Um, mm, in some cases, you can actually do it with some Python functions also, but sometimes it shows some error. But if it is a C++ function, then it is much more complicated. That I think. Now what so that is another thing, and then now what you can do, let's say you define and then redefine all these things, and you did some filter that, okay, I want this event, and only with certain criteria and all these things. Then what you can do, you can let's say now want to create a new root file. So that also you can do, and the command for that is df dot snapshot, where you can actually you can actually store the after defining, redefining, and filtering everything, you can store the final result in a. So this is very useful sometimes, that in a huge data set, what happens that you can have many variables. You don't want to remove those data files, but you, from that, you can customize your own functions and only store a reduced set of data and reduced a number of events. Then this is a very useful thing. And then the syntax here is actually the t name first, and then the output file name, and then the column names that you want to store. Okay. So if you do it, then you will see that one file output.root has been created. Okay. Now if you actually open this, and now remember that this data set has the tree name selected tree now, and you can actually see that it has only these three columns: HT, ZPT, and custom, and its entries are this. Okay. So that is the reduced data set that you can actually create. Um, Okay, so with some, let's say, little bit complicated example where you have multiple defines and filters. So first what you do is you create a new variable, then you create another column, um, which is the in central jet, with these conditions, and then you filter some of them, and then define a new variables. All these things you can do, and you can create a data frame, and you can reuse it later on. And then here, for example, then once you define this event category, for example, then you can actually do an analysis in a very easy way, that once this is defined, you can select your event category. Let's say in this case, event category is a number of such central jet to be 0. That is one event category, and then another event category is number of such central jet to be 1. And then you can create a two new data frame, df cat 0 cat 1, and then you can use it. Okay. So that is these are some more examples where you have created a slightly different data set, but this is using Python function definition, and you can compute the data set here. Okay. So this is what you can do. And another advantage of this R data frame is that you can actually use it, and you can like extract the data in a NumPy format. Okay? So in this case, the syntax here is as NumPy. Okay? So you, let's say, create some variables, and those variables you want to store, and you can actually do it via NumPy array. Okay. And then you can create your own pandas data frame. If you are comfortable with pandas and manipulating your data in pandas, you can actually then create a pandas data. This should be pandas, and then you can see that you can actually extract the data from this to pandas. So shall I stop here now, and then I have small thing, but or I just finish it to the end? Hello, am I audible?
Uh, Taushik,
Uh-huh. Yes.
can I ask a doubt at this point?
Yes, yes, yeah.
So, can I directly store this R data frame into a root file?
Yes, yes. That is the example that I showed here, right? Our data frame via the snapshot command. Yeah, yeah. So you can actually choose the columns that you want to store. Let's say in this case, only these three columns will be stored, and then name of the files, and the tree name. Okay, so now you can have a new root file named output.root, okay, with tree name this, with branches this. And this will be, if you apply filter, so the stored data will be after applying the filter. Whatever data frame it now contains, sorry, whatever data it now that this particular data frame contains, if you use filter, if you use new define, everything that will be executed, and only these columns, and after applying the filter, it will be like stored this new file.
So, if I don't give these branch names,
Then okay, let me try that. I think it will store the whole data set then. I have never tried that. And then let me see that what are the things it contains. Yeah, it stores all the things. whatever it has created in the during the process of define, redefine, and filtering, it will store. But since there are some filters that has been applied, you can see that the new data frame that has been loaded from the output.root should be it does not have any filter or something. Maybe no filter has been applied in this. But let us say if I, for example, store the df, which has some filters in it, it will store, and then this new data frame has only 783. Okay, so once you filter some of the data with certain conditions in the df, then it actually filters out those events. Now let me come to the part where I want to show that once you have this data, you can actually create histogram directly from here. For example, the simple command is this uh, histo1d command. So if you have a data frame, let's say df, which has been like filtered and defined everything, and then you have a column name met that you want to plot. So this syntax is you give a name which will be used internally. This is not the thing that will be printed, but this is the name that will be printed as the title of your plot, and this is the bins, number of bins from the x min and x max. It will be printed, and which column will be plotted, that is given here. So do not get confused that this and this has to be the same. So this can be like missing transfers, transfers. So this is okay, but this has to be the column name. And in an alternate way to define it is that you first define all these things in a model. So that you need a root.rdf.th1d model, the same thing, and then you can use that model to be your model for the histogram, and then you can actually create the histogram. So these are two alternate ways to do it. And then in order to see it, what you have to do in the root that I did not actually talk about, that you have to create a canvas with certain specifications, and then you draw and you can save it. For example, once this is created, you can actually go and see that this has been created met.pdf, and it gives you a histogram. And let me go here again. Okay, you can create a 2D histogram plot as well. So in that case, you have to have. So let me say that I have actually defined two new column, PT0 and M0, with ZPT, leading ZPT and ZM, and then these are some syntax to like comment out the legend part, and you can just like before, you can do a H2D model for this, and for this the syntax is, this is the name that will be internally used, this is the title, this is the pt of the sorry, this is the x-axis, this is the y-axis level, and then x-axis bin number, x min, x max, and y-axis bin number, y min, and y max. So that's the syntax, and then you can use this model to plot this, and with these two column names that you want to plot, and then you can actually save and see that another PDF will be created. Wait a moment, and it will be created here. This one. Okay, so it will create a 2D histogram plot with ZPT and ZMAX. So this also can be done directly from the R data frame. And for the scatter plot, so what you can do is you can actually define this in an array with numpy array, just like before, and then you can put some selection criteria that it has to be at least one jet event with the leading PT. So this is a simple Python, and then you can actually plot it just like before via matplotlib, and you can do many more things. So this actually ends my lecture. If you have some questions that I can take. Before that, just let me conclude that our data frame is another tool, just like Uproot, but which is very intuitive and powerful tool to handle data, store data, and redefine new columns and execute those columns and filtering data, and in a very intuitive way. And later on, this can be easily integrated to NumPy or Pandas or even internal root plot modules. Okay, so that is what I just wanted to say you today. And let me go to the question answer session, and then we can go to the quiz. Is there any question? Hello. Okay, I think there is no question. Okay. So are all people actually tried installing root? Hello. Yes. Everyone. Okay, so I will share this notebook with you people, and you can actually try all these things on your own. And okay, so I think I have done it. And Ritesh, are you around? Atul, you know whether Ritesh is around or not.
Yeah, I think so. Is here.
Then we can go. Someone. Everyone said yes, yes, yes. Someone said no. Okay, so yes, yes, you can actually. You can ask questions in the Slack channel. Uproot is easy to install. I don't know why you are having problem. If you have pip install enable, then you'll be able to install Uproot. But it says Python is no longer part of root. So this is during the installation of one. Ah, I cannot hear you. No, no, you're muted.
Yeah, this is during the CMake.
Yeah. Don't know exactly why it is happening. Python is okay. So you you should not install within the Python shell. Right? Are you going to Python shell and then trying to install root?
No, this is standalone.
Okay, so then,
See, I ran this command.
I see. It should work actually. Is it D Python? Okay, so I don't know. This is 6.334.08. So that version I never installed. I have tried version 6.26.12. Sorry, 6.26, 6.28.12, 6.34.02. I think I have tried, but 08 I haven't tried. So let me try that if I can. So I will try that and I can actually give it.
Okay. Okay.
While loading branches in T browser, does it consume RAM? It consumes some RAM. Yeah. 6.34 is probably the latest one. Okay, so we can go for quiz now.
Hi, Tousik. Hello.
Hello. Yes. I'll stop
Tousik.
share now. Hello.
Yeah.
Yes.
So do you want me to start the quiz or something?
Yes. Yes. I want you to start the quiz. So, how much time shall we give? It has 15 questions. So,
Sorry, no, so I'll share the link and I will time it. It's not going. My internet is poor
so I'll
today.
stop presenting now.
Can you or should I start?
Yes. Yes. You can. Yes, the link will be shared here. Some issues we're having. Yeah, after this, there will not be any lectures. After the quiz, it will be completed. This one. Hello. The link has been shared now. So I am timing it. So it will be for 15 minutes. Okay. So you can start answering the questions now.
How much time?
15 minutes. Yeah, there will not be any more in this session. I don't know whether there are announcements or not. If there are any, I would ask you to like stay for a couple of minutes. We have 2 minutes left in this quiz. Someone is saying they're no longer accepting requests, but it is accepting requests from me at least.
Tousik, will there be any lecture after this? After the end of quiz?
Yes. No, there will
Huh?
not be. Yeah, this
Okay,
is the
so
end of.
then whoever has completed the quiz can leave.
So we have 30 more seconds in this quiz.
Yeah.
So I'm closing the quiz now.
Okay. 63 respondents. I think we can close the quiz. And I think we can also close the session.
Yes.
Yeah.
Okay, so I have closed the quiz now. Okay, yeah. Thank you for joining in. We can close the session now.